Hello and welcome to the next episode of Python for Chemical Engineering Calculations. Today I'm going to talk about NumPy, numerical Python. It's a Python library which adds supports for arrays and matrices to operate with data, and it adds support for high-level mathematical functions to work with these arrays. So it's fast and it's convenient, and I'm going to show you how it works. So let's start from a very basic example when we need to work with some data using Python lists, right? We can do that, right? Let's say we have a list A of 3 elements, and we have a list B of also 3 elements, right? And we want to calculate the element-wise sum of A and B. If I do C equals A plus B, well, it's certainly going to give me something, as you can see here in the variable explorer, but not what I want. It will give me a list, which is a result of adding these two lists together, concatenating them. So in order to get an element-wise summation, I will need to introduce a new empty list, let's say D, and then use a loop which goes element by element through my arrays, also lists A and B, and for the new list D, I need to append the corresponding element of A plus the corresponding element of B. Okay, you can look here for the D, or I can print it here as well. It gave me the result I wanted, but look how many lines I needed to write in order to get these results. So in NumPy, this can be done much easier, and this is what is called vectorization. So in NumPy, I would be able to do exactly this and get this result. So let's see how it works. So first, NumPy is a library, it's a module, so we need to import NumPy. Well, typically people use an abbreviation NP for the NumPy, so use the following. And then I create my arrays A and B. I will use capital A and capital B to distinguish them from the lists I used before, and the syntax is the following. So A is a NumPy array, and then in the brackets I give this list which I wanted my array to be, right? This is A. You can see it here in the variable explorer, and note that the type of the A capital is different from the type of A small. It says array of integers 64. Well, it's an array of integers with the size of 3. Okay, then I'm doing the same for my B, and now I'm introducing my C is A plus B. And if I print my C, if I print my C small, this is the list I had before, but if I print my C capital, I will have an array of 3, 4, and 5. So exactly what I wanted to do without any need for loops. A couple of more things about creating NumPy arrays. So if I already had lists like A or B or C, I can create a NumPy array as simply using these lists, right? NumPy array of C small, right? So now D is this array of the 6 elements. By the way, note this array is an integer array, as you can see in the variable explorer. If I want to use floats, and often I want to use floating point numbers, I would do the following. I would do E equals NumPy array C D type equals float. And now if I print E, it shows me the dots after the numbers. If you look in the variable explorer, it shows the type is array of float. Well, of course, these are one-dimensional arrays. Similarly to lists, which could be lists of lists, I can create multi-dimensional arrays. For example, I can create matrix 2 by 2, F equals NumPy array, and then I create here a list of lists. So the first element would be one list, and the second element would be another list. So that way, I'm creating a 2 by 2 NumPy array, which is essentially a 2 by 2 matrix.